So I wrote this article called Conversations with Google. And it's about Amy. She wakes up, has a little chat with Google, sends it on task. Google does stuff, comes back to her. They go back and forth, chat about things. And she's getting into some of the medication questions she's having. Google's doing research, coming back with findings, and so on and so on. So I propose what type of data Google has about her, explicit, implicit, hidden, and so on. And as you can see, we've got understanding of the user query, multimodal search, personal assistant element, human facets, data retrieval, and so on. And these, the article details about all the things that go into the personalization. This is a very short talk, so I can't detail on each one, but I'll leave this list with you because you'll get the slides so you can peruse this. So I also propose an index of one that will come in addition to the knowledge graph, the link graph, the social graph, and everything else that we have. So me graph, the graph of one person. And so she's using Google as the organizer, as a conversation model to interact between the machine and her to rid herself of all the gadgets that she has. You might say, well, so what? That's just Gemini, right? But I wrote this in 2013. And some of my readers said, what do you mean? Do you think in 10 years, Google's going to be like a chatbot? And I said, that's exactly what Google's going to be like. And here we are. So the evolutionary timeline of Google that I predicted 10 years ago is still on track. And if you read through that, you will find exactly what happened and what will happen still. So this stuff has been coming for a long time. We've had people dreaming up to talk to machines for a very, very long time. And as work of fiction progresses, we've had the actual science keep up. We've got Asimov, we've got Clark, we've got pretty much at every step of the way. And weird thing is, like, it's all in the sevens. So this is the 2001, this is the Star Wars, and we've already got TF-IDF. Computer, do this, do that. BM25 was already there. We were starting to play with backpropagation and convolutional neural networks, Jan LeCun. Jodie Foster talking to computer, enhance, increase, this and that, reduce noise. So as you can see, PageRank was already invented by then. So 2007, voice search. And then we had transformers from Google Brain. In 27, it'll be the agentic web, basically. And in 37, AGI, coming out of China, probably. So 50 years of the evolutionary timeline leading up to transformers had a little latent history that I wanted to talk to you about before I get into the meat of it. So when Google invented the transformers, OpenAI paid attention and they were like, ooh, nice. Now we made GPT based on the architecture that Google invented. And so this guy called Alec Radford in 2018 decided he's going to have 12 layers and 768 dimensions in his model. Why? Because that's what would fit on his computer at the time, and it would train for a month. And that was at the edge of his patience. No other reason. So Google went, ooh, okay, GPT, that he must know what he's doing. So we're going to make BERT, and we're going to use 768 dimensions. And while they were doing that, something interesting was happening in the background. So mind you, these were tiny little language models. They fit on your laptop now, and you can run them. At the time, everyone knew that tiny little models can learn a little bit. Small models can learn really well. If you have a large model, they learn everything, and that's a bad thing because they overfit, they learn for the exam, and they can't generalize on very tasks. So the number of errors that the model makes grows bigger the model is. Until this lunatic came along, and he was like, I don't care, let's make models bigger and bigger and bigger and bigger and see what happens. And what happened was double descent. So he scaled models to crazy levels, and he noticed that the number of errors was reducing. Guess who was paying attention? Google and OpenAI were like, wow, so we can increase the number of parameters and get more intelligent models. What happened next is they said, okay, from 100 million parameters, 1.5 billion parameters, we're going to have a gigantic model. And then 175, God knows how many parameters they have now, trillion. So we have these huge, humongous models, and this is where we are now. We have these ginormous things that we have no idea what they do and why they do it. And if somebody tells you that they know how LLMs work, They're lying. So there's you, there's me. I'm going to be like poking my stick at it and trying to figure it all out and tell you what I've found so far. And this is basically the state of marketing industry right now. But the good news is we're not alone. The creators of these models don't know what the models do and why they do it and for what reasons. It's completely unknown. These models have something that's called emerging capabilities. Researchers don't know why their models work. They know that they work, but they don't know why. And so we have to accept this truth as marketers, that we don't understand the models. Something that you need to be aware of in machine learning industry, there's something called mechanistic interpretability. This is a new discipline of machine learning that is in charge of understanding what models do and why they do it on a very, very advanced level. One of the leaders in this space is Mira Murati. She left OpenAI, started Thinking Machines. Keep an eye on her and her work. And of course, this guy, this is the world's #1 SEO. He doesn't even know. He is literally like a genius that works in Anthropic at the moment, but he's worked at both Google and OpenAI. And he's literally in charge of reverse engineering artificial neural networks to understand, basically translator, model whisperer. He talks to the models and translates to human terms. So what did I do when I started with this whole thing? Well, I thought, well, if I'm going to have a claim that I understand AI, and I use that as a loose term, right? I decided to train my own language model from scratch. And I don't mean like took BERT or took some Llama or Mistral, something open source, or Gemma. No, I started from nothing, plain noise. So no fine tuning, no pre-training model. I trained my own tokenizer and trained the model on mass language modeling, where model has to predict where the bits of hidden parts of the sentences. So I had many training rounds, and I managed to get the model's loss all the way down to acceptable levels. So why am I saying this? Trust me, I know what I'm doing when it comes to poking a stick at the model, at least. So what does the model think about your brand? So this is the old Google. This is the new Google. You put in a prompt, Google Googles itself, comes up with some answers, synthesizes everything, and that's what the user experience is now. So we've got a user typing something in. We've got the fan-out queries breaking up the prompt into constituent parts. Each one does a normal organic search again and again and again for every single one of those queries. All these are the grounding candidates. A little classifier in the background then filters this down to a final selection that is presented to the model. Then the model, somehow, with its own little opinions about things, makes a decision what it will include in the grounding. This is the area of my research. I'm trying to figure out what the models select, why, and why do they prefer certain brand over the other brands. Are they associating your brand with certain thing or the other thing, and why? So two new concepts I introduced are called selection rate and primary bias. Selection rate is equivalent of click-through rate, but for machines. And selection rate is essentially determined by primary bias of the model. It's what model thinks when it's not grounded yet with search results, what it thinks about your brand and whether it knows it at all and what terms it associates it with. So all that is essentially text input. We've got SERPs and we've got the original prompt that the user entered. So those two get combined and you get one plain text output. That means all your fancy schemas and things and all that mashed up, and model only receives text. Then the citations are applied to that piece of text in respect to the grounding chunks that the model was presented with from traditional search, organic search results. And that's what that looks like. That's the generated segment you see there. This is the grounded citation. This is the chunk that it was used for the snippet in a grounding citation. And on the left, you see what humans see. On the right is what the machine sees. Not quite. Machine has attention patterns. That's how transformers work. They pay attention to certain things more than the other things. But in fact, they don't even see text. They see tokens. But in fact, they don't see tokens. Each token is a token ID. Each token ID is converted to a vector. Vectors are passed through the layers of the transformer network, and in there is the attention patterns of these tokens. Now, when you put input in and the output comes out, each individual token is a vector as output that gets converted. So if you have word events, That's the token, that's the vector that comes out. And the another token, another vector out. So attention hotspots within the network of the model is what drives the model's patterns in thinking about the brands. So on SEO, we have understanding and control, figuring out algorithms, controlling them through action. And in machine learning, we have mechanistic interpretability, and we have model steering. Complete analogs and complete equivalence. This is what to pay attention to. So, understanding. Visibility tracking. What I do is I define the brand, primary entities, the brand the stuff that the brand does, and in that location. And then I ask the model, list 10 brands in Australia they associate with that thing. And then I get the list, and I do the opposite. Entities towards brands. What brands do you associate with that entity? So, I measure that over time, and I look for changes in the model's output. Did you notice how I don't do the full prompt? I just do a very structured thing, and the model can't say anything but the list of 10. I'm not interested in natural language processing. I'm not interested in sloppy, busy work. I'm interested in structured output and distillation of model outputs. So what do I do with that information? I monitor frequency and rank. Frequency is how often does my brand appear for that entity that I just asked the model, and rank is when it appears, how high was it on the list of 1 to 10. So I normalize the two values, and I present them as a weighted ranking score. So what I noticed is that some brands are always sticky at the top. No matter what, model always mentions them. No matter how many times I prompt, they're always at the top. That's a sign of authority. If you see a lot of oscillations, that means lower authority. So this is how we express this. Frequency, position, weighted score. And this is the formula we use for the weighted score. Basically normalized frequency and position, and the weighted score is an expression of model's visibility for that entity. We can then run the most influential brands, most mentioned brands, and so on. All these sorts of wonderful analysis. This tracking framework is free. You just go to DEJAN AI and log in with Google, and you can track your own brand and entities in there. All this will be available to you later on. So model probing. How do we understand what model's actually thinking about your brand? So every time model says something, it wants to say some other things. And depending on the other things that it says at that moment, it changes the whole sentence. So you have sentence A, B, C, D, and so on. So every time you have a different token, model says something else. So that means that every time you change a thing, the output of the model is completely different. And that's ripe for analysis and studying. So we asked the model, what do you think about this brand? What does it do? So the model, when not grounded in search, says one thing. When grounded in search, it says another thing. What we do, we observe the model entropy, confidence in what it said, how likely it was that it was going to say that, and how unlikely it was to say that. So we in this screenshot see that it has very, very high uncertainty on certain tokens, but low uncertainty on certain tokens, which means it's very confident. And then we can express this as a graph. So what do? We focus on the bottom part and try to optimize for those things where the model is not so confident about the brand. We also can see in the model's head and see all the things it wanted to say, but it didn't. We call that parallel universe. This is the graph on the right, the matrix that you see. That's actually not sorcery. It's part of the API output of the models. You just need to dig into it. So this is what one model completion sentence looks like. What do you think this brand does? As you can see, some high entropy items in that sentence. And also they're marked in red. So we spot these things where the model says, oh, it said innovative, but it's very, very high entropy. Model could have said innovative, or it could have said anything else. So that's a flip point, the junction point where the model could have said anything else about the brand. So we look for pattern, syntax, preceding tokens, and everything else. We try to come up with the analysis. What are the types of things we should be writing about? What is that content we're seeding and citations that we're trying to do that is going towards actionable things that we need help with? So in this instance, we're asking the model, what does this brand do? It's giving us the entities, and then for those entities, we ask, what are the competitors for that brand? It gives us the competitors, and we repeat the exercise for the whole lot, over and over again. For each competitor, would you recommend this competitor for that entity? Yes, no. Model output is a single token. We only care about the answer yes, and we ignore no, and we look at raw log probes for the model output in the API. And we determine the likelihoods of model recommending that brand for that entity at scale, and we have raw, refined, distilled, beautiful data that's ready for action. So this type of analysis can also lead to nice competitive matrices, so you can see where your competition is strong and where you're weak and so on. Then we do the sentiment analysis, mining of the model perception towards the brand, whether it's positive, negative, and so on. And then we look at the synthetic reviews and so on. So that leads to association mining because that is giving us something to do later on. Before we go into the, I suppose, citation building and brand mentions and so on, for the high entropy things that we're seeing as quite low, we like to do mining at scale. So what we do, we get into, this is a free citation mining tool that will give you just a one-off example of what we do. You type in a prompt, does the analysis, gives you the citations and the confidence score, how likely that citation was going to be relevant to that grounding chunk. In an automated pipeline internally, what we do is we start with entities, we define the entities for that brand in a similar way that we did before. We define the prompts. Prompts are auto-generated by the model. So you can generate hundreds of prompts if you like. Then we do the actual prompting, and then we do the parsing of the output. And this is what it looks like. So we start with the entity generations. We can put this in manually as humans, what matters to us, so we can ask the model to define the entities. Then we generate the prompts. For each entity, generate 10 prompts, 90 prompts. So we use those prompts to mine and probe OpenAI Google, and we come up with 432 citation mining instances. Out of that, we already have the top domains where the citations are coming from, and the top URLs where the citations are coming from, exact count, and not only that, we get the confidence scores, we get the exact position of the sentence in the grounding source, and we can attribute each grounding chunk to the sentence that was generated. Why is this important? Well, we can also, with OpenAI, we can also see what model saw, but it didn't choose to include it as a citation. And that leads directly to selection rate optimization. This is part of the model's API. So, if you remember this slide, this is exactly what we were talking about. So we have the mapping, but now we have the full picture. We've got the text input, we've got the text output, we've got the source URL, and now the picture is completed. We've just closed the loop through citation mining, and we are ready for the cycle of AI optimization. Now, the visibility optimization is data collection, analysis, prioritization. So this part that you see, prioritization, that's that little token analysis and probabilities and strengths to understand where are the weak points. You can't do everything with citation mining. You want to focus your efforts, concentrate your efforts on the things that will matter the most to improve and bolster the moments where the models are weak about your brand perception, where you'd like to be perceived. So that forms a campaign, and the campaign goes into the loop of visibility tracking. On a more granular level, what we have is we've got the organic queries, and out of them we generate fanouts. We've developed our own query fanout model that we use. We can generate query fanouts at scale, and they give us an enormous scope of queries that we can do query mining for. So that gives us two things. Gives us the synthetic queries with a query gap that we're not ranking for, and gives us the query fanout so we can test and probe the negative biases and positive biases. That leads directly to on-page optimization and off-page optimization, because it's not always about getting citations. It's sometimes fixing your own content, but what do you optimize it for? You need to first understand where the weak spots in the model's head are for your brand and your products and services. So that leads to things like selection rate optimization, outreach, entity association, and so on. So I have built a phenomenal amount of tools that you guys can just jump on and use. So the list is quite exhaustive. I could talk 30 minutes for each one. In fact, I lost track of how many tools I have, so I built a list just for myself, so I'm sharing it here with you. They're all available for use, and they're a sort of demonstration and inspiration for you so you can think about what does the new SEO do in this whole confusing space of models and LLMs. This is now part of SEO. So I don't use any new neo acronyms. I just call it SEO. And I probably didn't say one word much. And I don't know if you noticed it. Like a lot of speakers will say this word a lot, but I mentioned it maybe a few times only. This whole presentation was about AI, but AI is now it's like an assumed part of what we do, and it's part of my brand. I inbuilt it in my brand in a very subtle gradient way. So all the things and tools and things and processes is what is Dan talking about? He was talking like this crazy lunatic, 200 kilometers an hour. The reason I'm talking high pace is because that's what's happening in the machine learning industry. New models every day, new methods being discovered every day. And we have to learn very quickly and we have to adapt very quickly. So if you guys are confused, lost, wondering how something works, how the tool works, you want to get down to the granular level of it, get to that URL, submit a form, and just ask me. I'll get your details and I'll just respond to you. This is not a sales thing. This is just for you guys to be able to reach out to me, exchange ideas, ask for clarifications, and collaborate. So I have about 5 minutes to wrap up. So I'll try to be really, really quick. So this is the next stage is to present my models and tools that I've built for the community. So these are our machine learning systems and models that are available for marketing teams, for tech geeks, and so on. So in my machine learning workflow, I use Facebook Profit, the good old logistic regression. I use mixed breed embedding model. I use FISE, which is Facebook AI similarity search. I use the query fan out model that we uploaded on Hugging Face. You guys can use it. We use LinkBird, the link prediction model. We use universal query classification model, AI detection, AI content detection model, and the content substance classification model. So the sentiment tool will be able to tell you whether sentiment is positive, negative, or neutral. We've got the LinkBird, which predicts natural linking within the plain text to help you with optimization of these entities that were not seen as strong as they should be. Query intent classification, which is now happening in Search Console, as I believe, just a couple of days ago. So we have universal search classifier, query fan-out generation, link spam algorithms, AI content detection model, and our old school algorithm for volatility, and its cousin Flux, which measures the volatility in AI search as well. Tree Walker is the algorithm that I've developed to find the high and low entropy completions in the model output. What I've been showing before is available to you guys. You can jump on Tree Walker, which will be at the end of my slides, the link, and you can probe your own sentences, your own models, what the models think about your brand. There's a brand relevance tool which does the probability for your brand. Is my brand relevant for this entity? Yes, no. And it'll give you the exact score, what the model thinks about your brand. AI Rank is a tool for AI visibility tracking. We've also got the LinkBird, Oxy for query gap, synthetic query generation and gap from your Search Console, citation mining. You can harvest the citations, go through the query deserves grounding. This model determines whether the query user entered will trigger the search grounding in the model or not. So you're not wasting your time on the queries that will not be grounded in search. So we've got one for Google, one for OpenAI. We've got content AI detection model. We've got another query fan-out generator that's based directly out of Google. Content substance classifier, AI Flux, Google brand and intent detection, Penguin, link optimization tool to avoid penalties, Chunk Norris, a tool for chunking your content, Google entity search tool, brand AI sentiment, text sentiment, Gemini token probabilities, and that is all. Thank you very much.